Hello, welcome back. Okay, 2.2. We are so smart, we can do 2 lessons in 1 day. Okay, so you guys know the quadrant plane, but I'm just going to review it just for funsies. So quadrant 1, and if you look at the little 1 in there, it has a plus plus. So that means the x is positive, the y is positive in quadrant 1. In quadrant 2, and again, see how it goes in a counterclockwise direction? Almost like a quadrant. So in quadrant 2, x is negative, y is positive. And in quadrant 3, both are negative. And in quadrant 4, x is positive, y is negative. So I think you all know this, but I don't know if you've paid attention to it. Like it's something that we know, but it's going to be helpful later if you know that right off the top of your head. I know in quadrant 3, sine and cos are both negative, you're talking. It will get better, I promise. This will make a lot more sense. But if you can do that right off the top of your head, you don't have to think about it or refer back to the picture. That's going to be helpful. But if you need the picture, it's right there. I don't know if you guys can see that. It's not very big. You're young. You have young eyes. Okay. All right. So my point is in quadrant 1. So let's pick one. Somebody give me a point that's in quadrant 1. Okay, let's use 2 different numbers. 3 and 7. I like 3 and 7. I feel like that's right there. All right. You guys have this over here? Okay. So if I were to draw in that triangle, okay. You guys have this over here? What's the height? What's the base? 3. Okay. What's the hypotenuse? I feel like we're in church and we're all reciting a prayer at different times. We can't simplify it? You sure? You're positive? Okay. Okay, so then I can't do anything with it. And 2, I can't do anything with it. Okay, so root 58. All right, so we pick some not great numbers. That's okay. Numbers are beautiful no matter what we do. Okay, now our theta is always measured from positive x-axis, that's our initial arm, to the terminal arm, and that would be our hypotenuse of our right angle triangle. Okay, so my theta is right there. That's a theta in there. So my angle is here, and will always be here. So some people say, but I can make this triangle against the y-axis. But then our angle is outside the triangle we just created. So don't do that. Our triangle, our theta is always going to be from our positive x to our terminal arm, the hypotenuse where it ends. Okay, so let's do sine, cos, and tan. What is sine of this? Which is? Okay, now, for the sake of time, I'm going to tell you not to rationalize it. But part of me dies on the inside when I say stuff like that. Like, I would not want to leave a square root on the bottom because that's just bad math. But I'm going to leave it here just for the sake of time. So please, no judging. Yes, I know you're having my birthday. Yeah, I know. But I don't want to do all the steps. Okay, so cos of theta is? Right, 3 root 58. Whatever. And tangent? Okay, you guys feel confident in that? That was just yesterday's lesson, right? Everybody can do this, no problem? Everybody can find the hypotenuse, no problem? I'm saying that like, yay, and you guys are like, oh, we're good. Okay, so again, to save us some time, we're going to use the same numbers but now we're in quadrant 2. So now my x is negative, but my y is still positive. So -3, +7. So if I draw my triangle in, so, all right, this is -3. This would be +7. My theta, now, all of a sudden, that's not really my theta anymore, is it? Where's my theta? So from positive to here, oh, I just wrote an 8, I'm not sure why. That's my theta. So what we have in this triangle, because we're dealing with the acute one, this one is my theta reference. What's an R by my theta? I don't know why we can't see that, but that's what it says. It says theta R, because my real angle is this orange angle. You guys agree with me? Okay. So now all of a sudden I have a theta reference. We're really good at 90 degrees, so we're going to stick with our 90 degrees. Hey, what's my hypotenuse on this bad boy? Root 58. See why I like to keep those numbers? That's exciting. Okay, so what's the sign? That's strange. What's coast? And 10? Okay, so my question to you guys is, what do you notice? X is the same. X is not the same. X wasn't the same. What did we notice? What did you notice between this one and this one? Sign's the same, right? Coast is similar, but what's different? Negative. So remember when I said in quadrant 2 your coast is going to be negative? I said those words.
One or three.
Oh, it will also be part. Sorry, I'm a big burner of fun. So what we noticed was everything here was positive. Here the signs were the same, but if you look back on this, my y was positive, my y was positive, right? So I anticipated that. Y is sine. Okay, so you guys just jumped to grade 12. So y is sine. The rest of you are like, I don't know what she's talking about. This will make all more sense to you when we throw this on a unit circle. Okay, is everybody comfortable with this? Yes, our signs are exactly the same. X is, you want me to tell you X is cos? X is cos. Okay. Cos is X. Yeah. So, yeah. Nope, we talked about this yesterday. What are the sign, cosine, and ratio, tangent ratios? Ratios just mean to leave it as a fraction. If I wanted you to solve for the angle, I would have said solve for theta. Okay? I did say that to you yesterday. It's good, you know. These are the weeks. Okay, so to save time again, we're going to use the same point, but now we're in quadrant 3. So I've got a -3 and a -7. -3, -7. What's my hypotenuse? Root 58. I'm so proud of you guys that nobody has said negative root 58. Perfect. Awesome. Okay. So for those of you who didn't catch that, if you're doing the Pythagorean theorem, when you square 3, it gives you 9. When you square -3, it also gives you 9. Right? -3 times -3. So the hypotenuse is always going to be positive. Okay? If you get a negative hypotenuse, something's run mathematically wrong. All right. So now there's my theta reference because that's my acute angle. On my real angle would be that. The orange is always going to be my real angle. Does that make sense, everybody? Right? Because we start with the positive, we go to the terminal arm, which is our hypotenuse. Okay, let's do the ratios. Sine. I bet you guys do this one. -3 over root. I made it 38. Look at me. Make that a 5. That would be good. And tangent. Okay, so a little piece of your math teacher dies when you do this. We never rate it as a negative over a negative. Sorry, I'll scroll up. We never rate it as a negative over a negative because a negative divided by a negative is a positive. So I wouldn't rate it that way. How are your thetas looking? How are your thetas looking? Are they looking good? Yeah, you guys good? All right, okay. Ah, okay. So all of a sudden you're making some rules that are awesome, that are going to not lead you wrong. So we know in quadrant 1, everything's positive. We know in quadrant 2, our sine is positive, but our cos is negative, and our tan is negative, right? In quadrant 3, sine's negative, cos is negative, tan is positive. Anybody want to make a prediction for quadrant 4? Okay, so if you're not making that leap, that's okay. The prediction is that tan will be negative, cos will be positive, and sine will be negative. If cos and sine are different, then your tan is always going to be negative, right? Right? Exactly. No. Okay, don't ruin the fun. Don't ruin the fun. I don't know what colors I've used. I'll go red this time. Okay, so for measurement's sake, we're going to go same points. It's going to be a +3 and a -7 this time. My theta reference is right there. My real angle will start here and go all the way around to there. I know that my triangle will be a +3, a height of -7. Doesn't that sound weird to say that? A height of -7. It's maybe a depth of -7 sounds better. So we do our sine, cosine, and tan. So sine of theta reference is, what is it? -7 over root 58. Cos of theta reference is equal to +3 over root 58. And tan of theta reference is -7 over 3. Okay, can I tell you guys a secret? When you were calculating cosine values, so any value of any angle, you guys have your calculators in front of you? Can you get them out in front of you? Thanks. Okay, so any value on the entire, I'm going to call it like the 4 quadrants, the Cartesian plane, 360 degrees all the way around. Any value of an angle for sine or cosine has to be less than 1. Okay? So what I want you guys to do is in your calculator, tell me the value of sine 30. You need to be in degrees, first of all. 0.5. You guys with me? Okay, with me? 0.5? Okay, perfect. I want you to do sine of 150. 0.5. Okay? So sine and cosine have to be equal to or less than 1 in order for it to calculate. A lot of times people are putting in values in the calculator and they're trying to figure out what the inverse cos
of 2.76 is. And that's going to give you an error because it has to be less than 1 or equal to 1. Okay? Tangent, on the other hand, as you can see, 7 divided by 3 is definitely going to be greater than 1, right? And that's okay for tangent. Tangent's the weird one. It does its own thing. Tangent, it can be greater than 1 values, but cos and sine can't be. Okay? Yeah, and that will work. We'll get there. We'll get there.
Okay, so now
What's your question?
like we don't see the value of this ratio. The ratio should be greater than the value than the b.
Right. Okay, so this is called the cast rule. Cast rule. Cast rule. Cast. Cosine, all, sine, tangent. Okay, so in quadrant 1, how many trig ratios were positive? In quadrant 1, all. In quadrant 2, which trig ratio was positive? Sine. In quadrant 3, and in quadrant 4, cosine. So the only thing I don't love about this rule is it'd be nice if C started in quadrant 1 because that would make the most sense. But I don't really know a word that would be ASTC. Yeah, like it's just not good, right? So we went with cast, and I don't know if it works or not, but it's a quick way to remember which trig ratios are positive where. Okay? So the cast rule tells us okay. Now, with that being said, that tells us where they're positive, but that, if you know tangent's positive in quadrant 3, what do you know about sine and cosine? They're negative, right? So although it tells you where they're positive, it also tells you where things are negative too. You just have to look at it in a different way. Is everybody comfortable with that? I'm gonna get tattoos of that later. Okay. All right. I'm gonna go back up to your pictures here. Okay. Okay. All right. So in quadrant 1, our reference angle was the exact same as what our real angle would be. You guys agree with that? Okay. Now in quadrant 2, and you can, I guess I should say this out loud. You guys know this. This is 90. This is 180. This is 270 and 360. Yes? Yeah, we all know that. So to find the real angle in quadrant 2, I could find this little angle. I know the whole thing is 180. So I just subtract it from 180, right? And then when I go to quadrant 3, I already have 180. So add my reference angle. Okay, and then in quadrant 4, my reference angle would be less 360, right? Does that make sense? So those are your quadrant rules right here. So in quadrant 1, the angle that you find is your real angle. In quadrant 2, when you find that reference angle, that's not your real angle. It's not your real angle, that's your helper angle. And in order to find what the real angle is, so real angle is the theta. Theta reference is what's inside that right angle triangle. you just subtract it from 180. In quadrant 3, you add it to 180. And in quadrant 4, you subtract it from 360. These rules are nowhere. Okay? These rules I expect you to know and memorize. Okay? They're not anywhere on your formula sheet. They're nowhere. So you have to memorize these. Okay. I say memorize, but I think you could logically figure it out. If you're a critical thinker, I think you can figure this out on your own. But if you feel comfortable or you don't feel comfortable relying on your brain power on the test, because you're too busy worried about other things, then I commit these to memory. And if you get a permanent tattoo with them, I'm not going to do anything about that. Okay. So point -512 lies in the terminal arm of angle theta in standard position. Determine the exact values of sine, cosine, tan. So it doesn't say solve for the angle. Just the ratios. Okay, so it doesn't say solve for theta, it says what are the ratios. So does it help you to draw pictures? It always helps me to draw pictures. I don't know about you guys. So -5, -12. Oh, it's a Pythagorean triple. Oh, it's nice when I pick the numbers as it works out. Okay, Pythagorean triple. We talked about this yesterday. You weren't even here. Oh, really? Yeah. I was like, oh, this is the one you need to remember, and then I don't remember it today. Perfect. All right, so there we go. That's my first step, is to get my hypotenuse. Okay. Well, I guess my first step is to draw the triangle. Step 2 is to get my hypotenuse. I find a picture helps me. Some of you are more visual people than I am, and you don't have to draw this. In no way do you have to draw this. This is not required, but I need it to help me do my question better. Okay? So what do we know? What's positive in quadrant 3? 10, right? Your casserole. Does it help you? I think it would help you if you're going to do the diagram to make sure you put in where theta is. So I'm going to have -12 over 13. It's your reference theta. I just would do that and explain that, but we've been doing that this whole time. Everybody okay with that? Those are the exact values. Because the question did not ask me to solve for theta. I will say that a lot of people lose marks on tests because they solve for theta and they don't give me the ratio. So know what I'm asking for. So I'm asking you for just what the ratios are. Okay? And I said exact values, and all I mean by that is if you have a radical, leave it as a radical. I don't want you rounding a decimal. Okay? That's why we did chapter 5 before chapter 2. All right. Okay, we're going to determine the exact value of cos of 135. So my question is, where is 130? Where does the terminal arm terminate? Second quadrant. Okay, so where's my angle measured from? You guys with me? You guys agree with me? Okay, for funsies, what would be the reference angle to this one? Oh no, 45. Right, my reference angle is going to be what comes up to 180. Right? I can use my formula. So the formula is theta equals 180 minus theta reference. This question gave me my real angle, so it goes in for theta. it has the math that goes behind it, but I think we all probably could have done that mentally in our head. Okay? But just so you see the math that goes behind it, I mean, it says determine the exact value of it. Okay, so let's look in our calculator. I know what it is. This is a tough one, determine the exact value. So if you do it in your calculator, can you guys do cos of 135? And again, just make sure your calculator is in degrees. Yeah, of course. Big coffee. Understand. Okay, what did we anticipate cos to be in quadrant 2? Cos is negative in quadrant 2. So it should not shock us that we get a negative value, right? And we should not be shocked that it has a value less than 1. Okay? So those are things that are going to help you figure it out. I actually know that cos theta, oh no, I don't, theta reference, of theta of this one is negative root 2 over 2. That's the exact value. I know that, you don't, we can do a unit circle, we can figure it out, but I don't think we need to. But if you want to know the exact value, this is what it is. Great, but I'm asking for the exact value. How do you know that? How did I know this?
Yeah, that's what I'm asking.
I did it with my unit circle. Yeah, you guys want to see it? Math was super fun. I will, but it will be something you know. Okay. Okay. This is exciting. Okay, suppose theta is an angle in the third quadrant. And we know, oh, I like giving these questions. These are my favorite questions. We know that cos theta is equal to negative 3 over 4. What are the exact values for sine and tangent of this angle? So again, not asking you to solve for theta, asking you to solve for ratios. So I'm in quadrant 3. So I know my terminal arm ends in quadrant 3. I know my what? These are so picky about like knowing stuff. All right. So it ends in quadrant 3 now, not quadrant 4. Why you just did that. So I know my point. Okay, so I know cosine is adjacent over hypotenuse. Now the negative sign isn't attached to either of those. You have to be smarter. What did we say our hypotenuse could be? Negative. So we know that that negative sign belongs to the numerator. Does that make sense, everybody? Because we just talked about hypotenuse. So I'm going to draw my triangle. My theta is here, or my theta reference is here. I know that my cosine, so adjacent, where's adjacent? And we said cosine was the x value, didn't we? Yeah. Isn't that what we said? Look at us. Tying all this stuff together. And my hypotenuse would be 4, right? Because cosine is adjacent over hypotenuse. We know hypotenuse can't be negative, so it has to be the 3 that's negative. You're also in quadrant 3. So we know both our x and our y coordinates should be negative, right? Okay, so what do? I gotta find the opposite side. So Pythagorean theorem. No? You can't find. Okay, that happens. No big deal. Everybody's like, it's a Pythagorean triple, 3, 4, 5. Why can't it be 5? Exactly. The hypotenuse would have to be 5. And this one didn't work out that way. So I'll do tricky things like that, challenging your understanding. Okay, so should my, and this is where the use smartness comes in. When we take the square root of something, we always do what's called a positive principal root. But we know we're in quadrant 3. So that should be negative root 7. Right? So that's a use smart thing. knowing that it's a negative root 7. That has to be you. Your calculator's not going to do it for you. So I did cos, so I need sine of the angle is equal to negative root 7 over 4. Right. And so they're both negatives. We also know that in quadrant 3, tan is positive. So if you write negative, negative, I might deduct you a full mark just because I'm angry at you. Okay? You made me cry. You're right. I got those backwards. Okay, go again. Sorry, Kai. They are theta reference. Yeah. Thanks. I was lost in what I was trying to fix. I was like, I missed something. Yeah. Hypotenuse isn't negative. No. My hypotenuse is 4 because it's across from my 90 degrees and it's the longest side. So if you did root 7 in your calculator, so it's 2.6, right? This is 2.6, this is 3, that's 4. This is still the longest side. Yeah. Okay, so you're going to be the kid who makes me cry, and I'm going to deduct a half mark. The negative 7 and the negative 3. And I'm not going to write them as negative divided by a negative. I would write them as positive. So if you write it as negative, negative, I'm going to get that 0 marks. What? Okay, everybody okay with that? Feel confident? I love it. Feel confident? Not really. Okay. So here's the thing, ladies and gentlemen. Yes. No, it's not. It's not. Okay. So here's the thing. You've now expanded your world. Okay. You now know that sine is positive. So we're saying 0.5 is a positive number. You guys agree with me? So tell me on the coordinate, the Cartesian plane, the coordinate plane, how many places is positive? So we know we're going to have answers for this in quadrant 1 and quadrant 2. So all of a sudden, your world was small and it was locked inside a triangle. Now we're looking for your answers in all 4 quadrants. Sine is positive, so this tells me that this is positive, so I get that. So I have 2 answers. Okay, so sine of 0.5, so in our calculator, is going to equal to sine -1 of 0.5. We talked about this yesterday. I'm not sure how you put it into your calculator. Your calculator is going to show you 30 degrees. Okay, is not my quadrant 1 or my quadrant 2 answer. My quadrant 1 answer. Because it's less than 90, right? Okay, so now to figure out whether, right, now you use your rules. So for quadrant 2, and I put subscripts on quadrant 1 and quadrant 2 just to keep myself organized. You do not have to do that. That's just me trying to keep organized. This is going to be 180 minus theta reference. Now, theta reference is the exact same value in quadrant 1. Theta and theta reference are the same thing in quadrant 1. So, 2, and so it's going to be 150. Please note that I have a degree symbol. It is required. Okay. All right. Okay. So the negative tells us what quadrants are we in? 2 or 3? 2 or 3? Okay. the negative tells me, I'm in quadrants 2 or 3. Then you drop the negative. Okay, because we're going to find the reference angle for this. So I'm going to do cos theta of root 3 over 2, but now it's positive because I'm finding that acute angle in quadrant 1. Okay, it's my reference angle. So everything in quadrant 1 is positive. So the only thing we use this for is to tell us where our answers are. We're going to drop the negative, and we're going to figure this out. So in your calculator, can you tell me, using my theta reference, so theta reference is equal to 30 degrees. Okay, this is not a solution. In this case, it was a solution because sine was positive in quadrant 1. This is not a solution. Where are my answers? 2 and 3. So rule for quadrant 2 is 180 minus 30 gives me 150. And in quadrant 3, 180 plus 30, which gives me 210. So these two are my answers. The reference angle just helps us find it. Okay, so if you get a negative number, it tells you where to look for it. Drop the negative, find the reference angle. Can you guys do me a favor? In your calculator, can you do second function cos of negative root 3 over 2? No, this. No. No. You got a 150. You should get a 150. So in my calculator, I do cos second function of root 3 over 2. I'm going to get 150. But okay, so the reason why I don't want 150 is because 150 gives me my first angle. I don't ever use 150 to find my second angle. Yeah. You didn't put the negative in. You drop it. Okay. Did you get it? I'm waiting. We're waiting for you. We're all staring, we're looking, we're waiting. I love it. I'm getting up to you. Okay, did you get it? Yeah. Oh.
It's weird, but so I do 3 roots. You have to do 3 roots, and then you hang it up after you put it, and then divide by 2.
I did that. You still got 30.
Oh, I think you keep the negative. You don't keep the negative. Divide by 2. You stay positive. Then you bring that cosine, and you get 30. But if you do 3 roots, make it negative. Divide by 2.
Okay, I've given up. I moved on. It's okay because you're always going to be finding a positive reference angle. So I would suggest that if I have to pound on the number 3, then maybe it's time to let that calculator go. Okay. So I use the negative to tell me where I am. I drop it to find theta reference. And what did I get for that? Okay, so let's round to the nearest whole degree. You know what? No, because we only round in our final answers. So we need to use, let's use at least 4 decimal places. Okay. 4 47.5225 degrees. Did you put your degrees? Yeah. Yeah, right now. Yeah, but this one is required. Okay. Yeah. Okay, so this is not an answer. This helps me find my answer. We drop the negative to find theta reference, and now the rules are in quadrant 2, it's 180 minus 47.5225. So I'm going to get 132.2. So 132. Okay. And then what would be our second one? So in quadrant 3, 180 plus 47.5225. So that's going to be 226, 228. 228 degrees. Okay. So I think the last example you can do